The content of this video, as well as the thoughts, views, and opinions expressed herein, belong to the presenter and do not necessarily reflect the views of Brigham Young University or the Church of Jesus Christ of Latter-day Saints.
Welcome, intrepid learners. I'm amazed that at 4:30 in the afternoon, here you are. That's wonderful. I'm John Lamb, Emeritus Professor of Chemistry from here at BYU. And we're going to talk today, let's see, what am I going to talk about? Oh yeah, drawing back the cosmic veil, science and revelation in the latter days. We're going to talk about that over the next several days together. Today, we'll be focusing on God's universe revealed. Science and religion. Are they at odds? Are they always at odds? It turns out that in the latter days, in the last couple of hundred years, things have changed as we try to answer that question. Science has made great strides, as you know, because of research that's being done around the world. But it's also true that in religion, we have been blessed greatly by the restoration of the gospel and some important revelations that we're going to talk about together today. Our focus is on areas where apparent conflicts have been resolved. Yes, there are conflicts between science and religion, but because of the things that have happened over the last couple of hundred years, some of these have been resolved, especially in light of the restored gospel. And this is going to be helpful to us, I think, because it gives us confidence for other areas where issues have not yet been resolved. Confidence that given time, and the more we learn in both these areas of human endeavor, that these conflicts will indeed be resolved. And that's something to look forward to, isn't it? Of course, science and religion have a common goal, and that is to find the truth about the world, about ourselves, about God, about our relationship with Him. And those truths that are found in these two areas of endeavor have to conform, they have to coincide, because there can really only be one truth. Truth is one great whole, as we know. Science contributes greatly to our standard of living and the way we live nowadays, doesn't it? When you think about all the things that are around us in this room, the things that you have in your home, your car, the clothes that you wear, these all are a result of the science that has been developed over the last few hundred years and make our lives much more enjoyable than was true before this time. And of course, for those of us who are scientists, getting in the lab and playing with things and blowing things up, as I plan to blow you up today, is lots of fun as well. Well, let's begin our conversation about this topic, talking about the universe at large. We'll talk about the big scale of things, the nature of the universe on the grand scale. Now, science as we know it, and we'll start with science, but we'll be kind of bouncing back and forth between science and religion together. Science as we know it had its origins in history with the Greeks, although they may very well have inherited much of what they knew from previous civilizations like Egypt, like the patriarchs that we read about in the Bible, the Mesopotamian civilizations. But as far as we can go back in history, it seems that we can start best with the Greeks. In about 430 BC, there was a trend among several scientists living in this part of what was then Greece, on the western shores of what we now call Turkey. There was one special scientist we'd like to point to today. His name was Democritus. And in addition to giving foundation to the kind of political system that we have, he was interested in the natural world. He taught that the world is made up of tiny individual atoms. This may seem familiar to you. And he proposed that there were many worlds with beginnings and endings, and many stars that these worlds were associated with. This teaching should seem familiar to all of us because it's what we learned in grade school, isn't it? But you know, it's interesting that these teachings had a kind of unexpected side effect when it relates to religion. Because what Democritus and his fellow colleagues were teaching tended to undermine the religious teachings of the day, because it presented a description of the world that was particularly mechanical, and the need for gods like Zeus and others to run the world as people had believed up to that point and continued to believe thereafter. The need for gods like that seemed irrelevant. And so we see the very beginnings, right from the beginning of scientific endeavor, the beginnings of this clash between science and religion, as scientists of the day were kind of undermining the belief in the gods that people worshiped. Now, it turns out, unfortunately for us as human beings, that that initial excursion into what we would consider to be legitimate science didn't last very long. It kind of died in the cradle, because within 100 years, those teachings were replaced by a different scientific model of the universe that was proposed and taught by philosophers like Aristotle, who had a fair bit of influence, by the way, because he was the tutor of Alexander the Great. And so Aristotle taught that the world was not made of atoms, that there were not many stars or other planets in the universe, but instead that the universe was constructed as you see on this diagram right here. The Earth is at the center, and the Earth is made up of these corruptible materials: earth, water, air, and fire. The reason that the Earth is at the center is because these materials have a tendency, their nature, as he described it, is to fall to the center of the universe. They're heavy. Heavy things fall to the center of the universe. Kind of makes sense on a commonsensical scale, doesn't it? And so it was easy for people to accept and believe this idea. Beyond the Earth were the heavens, and the heavens were made of material, of a completely different material called the quintessence, or the fifth element. This quintessence was a perfect, massless, and unchangeable material, of which pretty much everything else except the Earth was made. And the important thing here that I want you to remember is that these two different kinds of materials were what Aristotle taught the universe was made of, and that they were completely different in their character. Now, of course, this model of the universe that Aristotle taught was much more religion-friendly than was that taught by Democritus. And I just want to underscore, again, keep in mind this principle of Aristotle's philosophy. That is, different rules apply on Earth. We might say different laws of nature, if you will. Different laws of nature apply on Earth than in the heavens. This model, this teaching about the structure of the universe, lasted for a long, long time, much longer than our modern science has lasted, that's for sure. It was taught in the schools of ancient Alexandria and Rome and Athens and on into the Middle Ages, and we can safely say that it was taught in the schools for about 1800 years as the real structure of the universe. In fact, along about the late Middle Ages, along comes a famous philosopher, Tommaso d'Aquino from Italy, who formally adopted the Aristotelian model of the world into his school of teaching, which became known as scholasticism. And scholasticism was taught in the newly formed universities of Europe right up until the time of Copernicus, whom we'll talk about in a minute. Aquinas's objective was to harmonize Aristotelian philosophy, which was at the time being rediscovered in Europe after it had been lost because of the Dark Ages. And there's lots of interesting history that goes into all this, of course. But his job, his task, was to harmonize Aristotelian philosophy that was so highly regarded as it was rediscovered, including natural philosophy with Christian doctrine. Now, this was not really a hard thing to do, because just as the Aristotelian model had been compatible with ancient Greek religion, it was equally, possibly, compatible with the standard Christian religion of the day. We have, again, the earth at the center of the universe. According to biblical teaching now, it's corruptible, it's a fallen state. And above the earth, we have the perfect heavens, various layers of concentric spheres corresponding to various orders of angels. And beyond that, the permanent and unchangeable realm where God himself resides. Over time, as I said, this was taught in the universities for hundreds of years, actually, and became quasi-doctrinal among Christians. That is, if you wanted to be respected, you needed to believe in and teach this idea. We might say that it became kind of dogmatic in the traditional Christian church, that this was the correct and only biblically acceptable model of the universe that should be taught in the schools. And it became to the point in about 1500, when Copernicus comes on the scene, it became considered heresy to believe otherwise. So here comes Copernicus around the year 1500, a few hundred years later. And by this time, scientists were making much more accurate measurements of the positions and movements of the different planets, the sun and the moon. And Copernicus dared to propose that the sun was at the center of the universe, not the earth. He was condemned for this, but managed to avoid being burned at the stake for teaching something so heretical by essentially saying that this was a mathematical nicety. Really, the Aristotelian model worked. It was really true. It's just that if you considered the sun at the center, the mathematics of calculating where the planets would be and so on would be easier. So Copernicus started the ball rolling, and over time, more and more people, as more and more data were collected, realized that a sun-centered universe was really the only proper answer to describing how the universe is constructed. So in the late 1500s, we find people like Giordano Bruno here in Italy, who is teaching many of the very same things that Democritus had taught so many centuries before. And that is, the world is made of atoms, that there are many worlds with beginnings and endings, and that there are many stars in the universe. This was, again, a rejection of the established Aristotelian model. And unfortunately for Bruno, he didn't get away with doing this quite the way Copernicus did. He was, in fact, burned at the stake, not only for teaching this, but also for denying the divinity of Christ and a few other minor, aspects of Christian doctrine. So as time goes by, and Galileo, whom I'm sure you are familiar with, makes more measurements, there is a stronger and stronger case to be made about the sun-centered universe. Now, Galileo is famous supposedly for dropping balls off the Leaning Tower of Pisa. He did live in Pisa. Whether he did drop balls there, we don't know for sure, but his work was mostly in describing the motion of bodies on Earth like cannonballs. But he did pick up on the development, the invention of the new telescope in his day, and started looking out into the solar system and found that there were little planets revolving around Jupiter. We call them moons. He saw that there were phases of Venus. And the only way that you could really describe these things was to abandon the Aristotelian model altogether and adopt the sun-centered model that Copernicus had originally proposed. Now, turned out that Galileo was a friend of the Pope, which came in handy to avoid the flames. And so he was able to just spend the last 10 years or so of his life in house arrest for teaching the sun-centered model. We see now, over these decades and the last couple of 100 years we've talked about, we see that the conflict between science and religion on this particular question is heating up. The nail in the coffin for the Aristotelian model of the universe came along around the year 1700 with the contribution of very famous, one of the most intelligent people who's probably ever lived on the planet, Isaac Newton. Newton is famous for his description of gravity, right? He saw the moon and the apple falling from the tree, and considered how the moon was moving sideways while the apple fell straight down from the tree. If the moon was moving sideways, that would avoid its falling to the earth. It would continue to circle around the earth in an orbit. But to tell you the truth, even though Newton is really famous for inventing gravity, if you will, the biggest contribution that he made was not gravity. His big contribution came because he made the point that the law of gravity that he described was universal. And that's why I've put the apple and the moon up here together, because you'll remember that one of the foundational principles of the Aristotelian model was that there were a different set of rules that applied to objects on Earth and objects in the heavens. Objects on Earth, by their nature, fell to the center of the universe. Objects in the heavens, by their nature, went around and around the center of the universe. And they obeyed different rules or laws. That's the Aristotelian model. But what Newton is proposing here is something completely different. And that is the idea that a law of gravity that describes the motion of the apple, an earthly object, also applies to the motion of the moon, a so-called heavenly object. And so this distinction between what happens here on the earth and what happens out there beyond the moon is no longer the case. So when we talk about Newton, I think what we need to remember best about him is that the laws that he proposed, and specifically the law of gravity, were universal. And this idea completely upended what people had considered to be the nature of the world that we live in. No longer do we have heavens where God and the angels live, and the earth which is fallen and corrupt and where we live, but we have a universe that is universal. That's where kind of the idea of calling it the universe comes from. The idea that it is all the same. It's made of the same kind of materials, and they obey the same laws. This is a revolutionary idea, and it completely changed the way people saw the world. In fact, there goes Aristotle. He's gone now. The other innovation that Newton brings to the table is the idea that you can describe the laws of nature using mathematics. And we'll come back to that in another lecture, but that is a very important contribution as well. Bottom line is that Newton has described now a mechanical universe, a universe that where all the objects that we can see obey the same laws, and that these laws can be described mathematically. And from those mathematical laws, we can predict how objects are going to behave. Now, this takes us right back to the problem of the Greeks and Democritus, right? Because remember that this conflict between science and religion that we talked about in 300 BC, 400 BC in Greece is now re-emerging. Yes, different actors on the stage, but the same idea. This is going to create a problem for religion. The idea that the universe is like a clock, a mechanical thing that just runs by itself according to natural law. And the question then is brought up once again, just as it was in ancient Greece. What need do we have for God if the universe is a machine? And the other question is, well, where is he? Remember that in the Aristotelian model that had been so prevalent for so many centuries, if you wondered where heaven was, if you wondered where God lives, you didn't have any doubt at all where that was. All you had to do was look up in the sky. That's where God is, because he lives in a realm that is completely different from the here on earth. The realm of the quintessence, the eternal, the unchangeable, perfect spheres that surround the center of the universe. But now Newton has taken away our heaven. We don't know where heaven is anymore. And so that's one of the struggles that Christianity had to encounter when this whole new approach to describing the universe was created. Now, as time went by, all along the way, people are taking more and more careful measurements of the stars and the planets. And in the late 1700s, astronomers like these gentlemen here realized that there is a vast number of stars, just as Democritus so many centuries ago had predicted. And they called this collection of stars a galaxy. We call it the Milky Way. The idea was not that the Milky Way was one of many galaxies that we see here in the background. This is a modern picture. But they would have envisioned the universe this way, as one galaxy called the Milky Way, with many, many stars in it, but no other galaxies. That would be it. I mean, that was lots anyway, right? There are thousands and thousands of stars in the Milky Way. That's enough. So by the late 1700s and early into the 1800s, now we're getting to Joseph Smith's day, and that's where we're headed, okay? By the early 1800s, the universe was described in the Newtonian way as a mechanical kind of system with a large but limited number of stars. No planets, just stars. Our planets in our solar system alone. Now you can see how this represents a very great revolution in the scientific point of view about the way the universe is structured. What about what's happening in religion? Well, as I said, we were approaching Joseph Smith's time. Here we are, we're at Joseph Smith's time. What did Joseph reveal to us about the structure of the universe, and how does it compare to what science of his day was saying? Because in fact, you and I recognize that Joseph Smith was generating a complete revolution in theology, in the nature of the universe, the nature of God, our relationship with God, and so on. In 1836, the Kirtland Temple was dedicated. And at that dedication, William W. Phelps here wrote a number of hymns. And one of them is the Spirit of God. And in that Spirit of God hymn that we love to sing, there is this phrase, "The veil o'er the earth is beginning to burst." Sound familiar? You've heard that, right? Okay. Well, as a matter of fact, I think that phrase captures exactly what is happening here in the latter days. It had been happening a little bit previous to Joseph Smith's time, but it has happened in an accelerating way ever since. And that is the idea that there was a veil over the earth, and that gradually over time, as we grow in our understanding in both science and religion, that veil is dissipating, and we can see what's actually out there. And we can see what the structure of the universe really is. The contributions of Joseph were very important. This is from Moses. This is back in 1830, just after the church was organized. We read in Moses, "And were it possible that man could number the particles of the earth, yea, millions of earths," and keep that in mind, "like this, it would not be a beginning to the number of thy creations, and thy curtains are stretched out still." That's a pretty definite and bold statement. Then later, of course, Joseph translates the book of Abraham, and Abraham also is instructed of the Lord about the structure of the universe. "Thus I, Abraham, talked with the Lord face to face, as one man talketh with another. And he told me of the works which his hands had made. And he said unto me, my son, and his hand was stretched out. Behold, I will show you all these. And he put his hand upon mine eyes, and I saw those things which his hands had made, which were many, and they multiplied before mine eyes, and I could not see the end thereof." Now, this is a pretty bold picture of the structure of the universe as compared to what was prevalent in scientific teachings of Joseph's day. And then again, this is in 1843 when this Abraham was published in the Times and Seasons in Nauvoo. "Abraham received promises concerning his seed and of the fruit of his loins, from whose loins ye are, namely my servant Joseph, which were to continue so long as they were in the world. And as touching Abraham and his seed, out of the world they should continue, both in the world and out of the world should they continue, as innumerable as the stars. Or if you were to count the sand upon the seashore, you could not number them." I want you to try to remember this reference to sand on the seashore, because it's going to come up again in an entirely different context. So in Joseph Smith's day, there was an apparent conflict between what science was teaching and what Joseph was teaching. Here it is. Joseph's revelations say that there are millions of earths like this, and that there are stars like the sands on the seashore. By contrast, at this point, science hadn't got that far at all. Science was teaching that there is one known Earth in one solar system, in one galaxy, with an indeterminate number of stars. Knowledge, though, has been pouring down and continues to pour down on the children of God here on the earth. Notice that he promises in D&C 121, "What power shall stay the heavens? As well might man stretch forth his puny arm to stop the Missouri River in its decreed course, or to turn up the stream, as to hinder the Almighty from pouring down knowledge from heaven upon the heads of the Latter-day Saints." And you know, the Lord's pouring down knowledge on us in more than just one way, in many ways. Brigham Young made this clear when he said, "Every discovery in science and art that is really true and useful to mankind has been given by direct revelation from God, though but few acknowledge it. It has been given with a view to prepare the way for the ultimate triumph of truth and the redemption of the earth from the power of sin and Satan. I want you to take special note, special note of this phrase, that science has been revealed by God by direct revelation. And it's not like we usually consider scientists to be prophets and revelators, but as a matter of fact, God speaks to his children in many different ways. All of us are endowed with some measure of his spirit, and scientists and religion, as I mentioned early in our presentation today, have a common goal, and that is to find the truth about the world. Well, we talked about a little conflict there. What's happened? I'm going to make the case that that conflict has now been resolved. What's happened in the meantime now? We're getting into the 20th century. Here we are, this is Edwin Hubble in the 1920s with his gigantic telescope, okay? And he's looking out at these fuzzy spots that he finds here and there in the sky. And he realizes that they are actually galaxies outside of our galaxy, the Milky Way. I want you to make special note of the fact that every point of light that you see in this picture is not a star, but a galaxy. So he finds that there are many galaxies. Not only that, but that the galaxies are all moving away from one another. Fast forward a few more decades into 1990, and the aptly named shuttle Discovery carries this machine up into orbit around the Earth. You know what that is, right? What is that? That's the Hubble telescope. The Hubble telescope is a wonder, and for many years after it was fixed, has produced some of the most beautiful pictures you could imagine of what's out there in our galaxy and in other galaxies, like these kinds of dust clouds in our own galaxy, and nebulae, and other galaxies like the Whirlpool galaxy here. And this is an interesting one. This is a Hubble picture. We have the so-called pillars of creation. They're about 7,000 light years from Earth. That is, they're inside our own galaxy. And they are the place, or one of the places, where new stars are being formed and new Earths. Well, even more recently, we have the Webb telescope, which is a wonder. It's just amazing how they were able to pack this gigantic telescope, kind of like a transformer, into the nose cone of a rocket and send it up. Now it's 1 million miles away from the Earth. And let's see if there we go. This thing had to unfold like like a butterfly coming out of a chrysalis. It's just amazing. One of the most amazing things that I can imagine human beings ever being able to do. Here are the pillars of creation taken with the Webb telescope, which is even more powerful than the Hubble telescope, but sees in a different region of light that we'll talk about tomorrow. The Hubble people did a really cool experiment that I think that you've maybe heard of. They saw that there was a patch of sky that didn't seem to have any stars or galaxies in it. So they decided to do what photographers often do when they're faced with low light situations. They kind of figuratively opened the aperture of the Hubble telescope for 10 days, just left it staring at this one little spot in space. And they found that that seemingly empty region of space was full of, guess what, galaxies. When we look out further and further into the universe, we are able to see further back in time because the light that left those galaxies and stars took time to get to our eyes and to our telescopes. So the Webb telescope is looking back towards the beginning of the universe. We'll talk about the Big Bang here in a few minutes. And seeing some galaxies that were created not long after the creation of the universe itself. They're really fuzzy looking kinds of pictures. They're not glorious looking photographs that we have from Hubble of galaxies that are relatively close to us, just a few million light years perhaps. But these are baby galaxies. This is so far the closest, the furthest galaxy that we have seen is only 235 million light years after the Big Bang. These are baby galaxies being formed. Well, let's get back to Joseph's claim. Remember, we're talking about this apparent conflict between science of Joseph's day and what Joseph was claiming. How about comparing Joseph's claim to what we know now in science about the universe itself? That really requires that we count the stars, because Joseph's claim is that there are millions of Earths and numberless stars. Let's see if that's really true. To do that, we're going to have to count the stars. And of course, the easiest way to do that is to get a whole bunch of graduate students with a telescope and get them counting stars. Actually, that would be a kind of hopeless task. But there are just statistical ways of doing this that we won't go into. If you look out into the universe, you'll find that there are between 100 billion and 1 trillion galaxies that we can see in the so-called observable universe. And each of those is going to have between 1 and 1,000 billion stars. Now, these are big numbers, and we're kind of used to struggling with big numbers once in a while. We need to get a grasp of just how expansive and how huge these numbers make the universe appear. It turns out that one of the popularizers of modern science, Carl Sagan, used this analogy to help us understand how many stars there are in the known universe. He made the claim that there are more stars in the known universe than all the grains of sand on all the beaches of the planet Earth. Now that's a lot, but even that, I think, requires some close study to really appreciate it. I want you to imagine yourself on a beach, you pick up a handful of sand, and I bet you're just tempted to count the number of grains of sand in your hand, right? No, you're probably not even tempted to do that. Imagine trying to count how many grains of sand there are as you look down the miles and miles of beautiful beach that you're vacationing on at the moment. It would be an almost hopeless task, wouldn't it? And that helps give us some sense. Now, we could actually test this hypothesis quantitatively, mathematically. And we can do that fairly simply. Let's do it together. We're going to, because we're comparing stars and sand, and the claim is that there are more stars than sand, let's be conservative in our estimates here. We'll estimate low on the stars and we'll estimate high on the sand, just to give the some competition here and see if it'll really work. Well, if there are 100 billion galaxies with 100 billion stars each, we can simply multiply those two numbers, and that turns out to be how many stars there would be in the universe. That's 10 billion trillion, almost as big as our current national debt. Now, scientists have a way of trying to handle big numbers like this without having to write all those zeros. And the way to do that is simply to say this number, 10 billion trillion, can be represented as 1 times 10 to the 22nd. There are 22 zeros. We just say 22 zeros. How about the sand? Well, we're going to estimate high on the sand. Let's assume that there are 100,000 kilometers of beach on the Earth. There probably aren't. Maybe in your celestial world, you'll want to have that many beaches because it'll be like glorious Hawaii, the whole thing, right? But we're going to assume a huge amount of beaches. We're going to assume that the beaches are really wide and the sand is really deep. And we can go ahead and calculate how many grains there are in a cubic meter multiplied by the number of cubic meters that there would be in this huge amount of beach and come up with a number. Well, the number that I come up with is 1 times 10 to the 21, or 1 billion trillion. How does that compare to the number of stars? Turns out there are more stars in the known universe than there are grains of sand on this hypothetical, wonderful world of beaches. Okay. It turns out, by the way, that there is a huge difference between this number and this number. Think of it. There's a bigger difference between 100 and 1,000 than there is between 10 and 100. Imagine how much bigger 10 to the 22nd is than 10 to the 21st. It's just kind of mind-boggling. And so what's the answer to our question? The answer is yes, there are more stars in the known universe than there are grains of sand on all the beaches. And you can even add in all the grains of sand, by the way, on all the deserts. Why not? I mean, let's be generous. Now, these galaxies that stars find themselves in are not spread evenly, it turns out, through the universe. They're in a kind of a web. It's almost like a spongy universe. Each of the pixels in this picture is a galaxy, okay? And this is a kind of 3D video representation of how those galaxies are distributed through the universe as modern science predicts. Well, we can appreciate these numbers even better if we go exploring through the universe. Shall we do that? Now, to do that, we're going to have to go really fast, obviously. We've got to visit a lot of stars. What is the fastest spacecraft yet launched? Turns out it's the Voyager 1. It was launched in 1977. It's going about 39,000 miles an hour. It left the solar system in 2012 and entered interstellar space. But you know, this seems fast, but it just ain't fast enough, because it's going to take 700,000 years to get to the next star. I don't know about you, but I don't think I could sit with kids in a car that long. So we're going to need something much faster. Is there a speed limit? Can we only go so fast? The answer is yes. The speed of light is our speed limit. We can't even reach that really, probably. But that's really fast, as you can see here. What's the time if we go at the speed of light to the nearest star? Well, it's only 4 years. I guess we could handle that maybe. If we take along a lot of Fritos and M&Ms. Okay, so we're faced with a bit of a challenge here, aren't we? If we really want to take on the mission that the Star Trek Enterprise took on, and that is to seek out new life and new civilizations, we need to visit a lot of stars and check them out. And we're going to have to, I'm going to put Einstein back here, because we're going to have to kick Einstein out, all right? Because we're going to have to go a lot faster than the speed of light. We'll just pretend he doesn't exist. If we're going to do this, let's see here. What am I doing? Technology. Let's say we have a starship that is so powerful we can visit a new star every day. Every day. We're going to wake up, we're going to go to the next star, we're going to look at it, see if there are any habitable worlds there. If there are, we'll wave goodbye and we'll go to the next star the next day, and then the next day, and then the next day. And we'll do that without ever stopping to take a vacation, open our Christmas presents, do anything like that. We've got a mission, we're focused, we're getting things done. Well, what if we could do that and we visited each star in the Milky Way? It would take 30 million years to do that. I think I'd get bored of it. This is blowing Captain Kirk's mind, obviously. What if we narrow our search down so that we only visit those with exoplanets? That is, that have stars that have planets around them. Well, as of today, we have found that there are about we have actually found 5,000 or so planets around other stars. And we're starting to learn that there are planets around almost all stars. Researchers have calculated that billions of the stars in the Milky Way have 1 to 3 planets in the habitable zone even, where there is a potential for liquid water and where life could exist. This, yeah, we're narrowing it down, but it's still quite a challenge, isn't it? Even if 5% have habitable planets, it'll take us 1.5 million years visiting a new star every day to visit all the stars in our own galaxy. And there are 100 billion galaxies left to go. There goes his brain again. So I suggest you start making your travel plans with Travelocity for the resurrection now. Of course, we really are interested in finding the planets that have people, that have intelligent life. And science has tried to make a stab at calculating how many such planets there might be. It's called the Drake equation after this scientist here. And I won't go into the details, but the idea is to narrow down the number by choosing only stars that have a certain rate of formation, fraction of stars with planets, and so on. So how many of these planets might there be? Well, it turns out that this kind of back of the envelope calculation predicts that there may be millions of worlds with intelligent life in our galaxy alone. And this leads to what's called the Fermi paradox. Fermi was a scientist in the 1940s and 50s, 60s, who asked the question, why haven't we been contacted yet? If there are so many habitable worlds, the probability that there are aliens out there intelligent enough and powerful enough to visit us, we should have been visited by now. Why not? Well, certain excuses have been proposed. Maybe it's because there is a short lifetime of technical civilizations. They tend to blow themselves up. Or maybe civilizations are too far apart. It just takes too long and it's too hard to travel between stars. Maybe civilizations are avoiding us. We have some kind of interstellar BO or something. Well, it turns out that Joseph Smith has the answer to this question. The answer to the question is that we have been visited by extraterrestrials. We call them angels. Okay? Of course, these aren't the kind of extraterrestrials that Hollywood or most scientists would think of, because these extraterrestrials are a part of a vast interstellar and galaxy-wide and what's the word I'm looking for? I'm getting old, folks. Anyway, a vast interstellar plan to inhabit worlds with God's children, right? And he has a certain plan in mind about who should come here and with what message and what they should do and what should become of us over the time that we are living in this probationary state. We won't go into the plan of salvation in total, but I think you know where I'm coming from. Well, remember that Edwin Hubble told us not only that there are many galaxies in the universe, but the galaxies are moving away from us, and they're moving away from each other. And this is because the universe is not just big, it's getting a lot bigger. The universe is expanding. Now, this is not because there's more matter appearing in the universe, but rather because the space between matter, between stars, between galaxies, is stretching. Turns out that space isn't just nothing. It turns out that space is a thing that has properties like stretchiness. Who came up with this idea of the Big Bang and why? Well, if the universe is expanding now, if we run the clock backwards, then over time, we'll see the universe get smaller and smaller. And at some point in the future, the universe is going to collapse down to a point. And that is, in fact, the logic associated with the so-called Big Bang creation of the universe. So If we run the clock backwards, the universe, the material in the universe will be collapsed to a point. The space of the universe will be collapsed to a point. The time of the universe will be collapsed to a point. And so we run it back about 13.8 billion years, and we find that there's nowhere else to go. And the universe must have been very small at that point. And then we run the clock forward again. We find ourselves here in the now, 13.7 billion years later. Now, what kind of a bang are we talking about? Are we talking about this kind of a bang? This is what you came for, right? See, the bang produces galaxies that spread out. Thank you, guys. No, it's not that kind of a bang. Yeah, give them a hand. These are our fabulous chemistry department lecture demonstration personnel right here. What kind of a bang is it? Not an explosion with heat. It doesn't give off a flame, doesn't produce a big noise. It's the instantaneous or very short-lived expansion of the space and time in the universe. Okay, so the universe just blows out. And don't ask me questions about what's it blowing out into or anything like that, because nobody really knows the answer to those things. But this is, I guess, the logical progression, conclusion drawn from the fact that the universe right now we see is expanding and has been expanding for a long time. Expansion of space and time. Our understanding of the universe as we see it through our telescopes and so on is gradually evolving. We once thought, for example, that the whole world was our local area. Just the area around our village, maybe. Then we thought, as we saw more and more of the world, we thought the Earth was the only physical body in the solar system. Then we decided that the sun was the only star, that it was a star. Maybe then we look out further and we see the Milky Way. Well, the Milky Way was the only galaxy. Also, in the past, we've thought Earth life was the only life. Of course, now you hear scientists talk very seriously about life on other planets. We thought that matter was all there was, or that ours was the only universe. As Joseph Smith described correctly, and as William Phelps mentioned in his hymn, The Spirit of God, the cosmic veil is gradually being drawn back to reveal a universe that is beyond comprehension in scope. In Joseph Smith's day, there was an apparent conflict in his revelations that there were millions of Earths. And science in his day was teaching that there is one known Earth in one solar system, in one galaxy with an indeterminate number of stars. The Daily Planet has recently published this bulletin. The conflict there now has been resolved. Scientists now affirm that there are trillions upon trillions of stars in billions of galaxies, and many, if not billions, of habitable planets out there. And they now talk of endless universes as big as our own. It just keeps going. Modern science and modern revelation have recently come together in one truth. God's creations are literally beyond comprehension in scope and wonder. Remember, I said at the very beginning of our lecture today that our focus in these lectures has been to illustrate areas where apparent conflicts between science and religion have been resolved. And this is one of them. And this gives us confidence that where there may seem to be other conflicts that have not yet been resolved, that they will be resolved. And we can have faith, I think, in that assertion, because there is one common goal that both science and religion share, and that is the revelation, the revealing of truth about the world that we live in. Science provides the facts. Does religion bring something to the table? Sure. Religion adds to that meaning, the kind of meaning, of course, that we read about in the scriptures for the most part. Both these endeavors are revolutionizing our understanding of the cosmos and our place in it. We have an incomprehensibly vast universe that we live in. And here's the promise that makes all this seem so wonderful to us. In D&C 84, we have this promise. He that receiveth my Father, receiveth my Father's kingdom. Therefore, all that my Father hath shall be given unto him. I hope in this presentation that I've helped you understand just how all that is, that we can become heirs with Jesus Christ of all that the Father hath.